the second part of this session is actually the application scenarios. So here we will present examples highlighting the synergy and complementarity across the public EU missions and the private commercial assets. And I had a little bit of speech here, but really I will not go into more details. I will call our first presenters, Paolo Mazzanti. Paolo, here is Paolo. He's a CEO of NACTA, and help me, Paolo, Natural Hazards Control and Assessment.
So good afternoon, anyone, and thank you for the introduction. And thank you for inviting me to give this presentation. So NACTA is an acronym for Natural Hazard Control and Assessment, and no need few words about myself, but I'm a geologist as a background and professor of remote sensing and natural hazards at the University of Rome Sapienza. And 10 years ago, I founded this a company that is called NACTA. It was one of the first incubated at ESA program for incubation. At that time, not so many people were interested about natural hazards and the impact on infrastructures. So, but we continued with our mission that not change over time. So we are in the downstream sector, and we really like any potential that can come from satellite for analyzing hazards and taking care of our infrastructures. That's a relevant matter, and we develop a lot of project financed by public agencies, but our main mission is really to support construction and asset management companies and land management agencies. So why this is important? You know, everyone, that geohazards is a topic that is relevant to be considered, especially if you look at hydrometeorological hazards that are changing and growing, also following the change in the climate features and conditions. At the same time, infrastructures are aging. As I was telling you, 10 years ago when we started with this idea, okay, there are some bridges collapsing sometimes, some landslides occurring, but times isn't on our side. So things, unfortunately, are growing because of climate change, but also because of infrastructures that are aging, especially on developed countries. And so this is a matter that must be considered. Most of the infrastructure we are relying today was built 50, 60, 100 years ago. They were not taught for the present climate condition, and they were not taught to survive for tens or hundreds of years. So there is a time right now where this is becoming an issue. In this slide, just a few numbers on the investment on maintenance that are paid from transportation agencies around the world. ANAS is the Italian National Highway Department. It is our main clients, just to give you an example. And they are investing so much. This is changing drastically over the last decade, because before, most of the investments were done for building new assets. But at present, we have a good network, but this network is old. So we really need to take account of this. So what's the solution? Of course, anyone is looking for asset management solution. So to have potential of prediction, so that to have a driver for making maintenance in the right way. How doing this? Of course, this can be done easily as was done in the past. You go on the site, you look on your building, you look on your slope, you look on your bridge, time by time, but it's very time consuming and cost not effective, as people have to go there. It's also a little bit risky and cannot be done spread around. So for that reason, what we are suggesting is a smart approach, so taking advantage of Earth observation data. Earth observation data have some, as all of you very well known, quite unusual capabilities with respect to field actions. First of all, they can analyze large areas. And if we look at infrastructures, especially network infrastructures, they are really spread over large areas. They have no interference with asset operators, so you have not to block the traffic over a highway to make some inspection. You have data from the past. This is very important because having data from the past allowed you to start with a background information. And as you know, satellites for Earth observation are now on air since 50 years, and over the last decade and 20 years are exploded so much in terms of development. And the other point is you can track change and deformation, also in an accurate way with technologies that now are quite common. So the nice point for us is that there are so many options today. I think there are something like 1,000 satellites for Earth observation orbiting active right now. There are many others, and some of them has been presented before in the next few years. There are several public and private operators. So there are operators from the private sector that are growing, and we have so much differences in wavelengths, spatial resolution that can reach few centimeters, and temporal resolution that with the new constellations is also reaching daily revisit. That is a very great chance. So what we developed over the last year was a data processing technology that we call photo monitoring that combine image processing, data fusion, and artificial intelligence that allow to derive several information. Just to give you a very simple example, all of you probably know INSAR. INSAR is now becoming a very common technology, taking advantage of radar and synthetic aperture radar images. In this picture on the left, you can see images and information derived, data derived from INSAR. But there is some missing part that can be covered with other technologies like digital image correlation. And so combining this, you have an overall picture. So data fusion is very important from our point of view. At the same time, when you analyze something and you see that something is moving, is that an issue? Not necessary. And so doing classification with artificial intelligence is very important. So you can tell to operators, not just something is moving. There is this type of process that is going on. Take care. Combining also different wavelengths, for example, with synthetic aperture radar on X, C, and L band is very, very important. In this case, you see the differences for combining different technologies. So persistent scatter INSAR and differential INSAR on the left, and on the right, two different wavelengths, differential SAR data. And that's another capability to track at the end what is going on, where there is a process, which kind of amount of movement is observing, and so on. And the same thing can be done not only for linear infrastructures like railways or highways, but also for example, for dams, and can provide very interesting information like the discovering of a 10 kilometers long crack on the side of a dam that was not known to the operator. We are in Africa in this way. And of course, we can go in a country that is dangerous, like Sudan, in this case, just from satellite. So for me, that I come from, as a geologist from the ground, really having this chance is something that is fabulous, but also for operator is becoming really a great opportunity. And once you have this data and you combine with ground data, you can also understanding what is going on. And if you can understand, you can develop a model and you can predict. And so really prediction is exactly what is needed. In this case, in North America, Highway 1 in California, there was the chance to predict that failure that blocked this highway for more than 1 year with an incredible amount of money lost by this area. And once you have prediction, you can really do asset management and predictive maintenance based on this data. And for example, you have this asset, you are the owners, you see some data that seems strange, you can immediately tell them that there is something that must be cared, and they can go there, take their decision. So really, all these tools are a way to support actionable decision making. That is exactly a sentence that I've already heard before from the previous speaker. So trying to be exactly in time, I'm finishing. Thank you very much.